All right, we're back. We're on the bottom of page 328, and we will be doing a problem that feels a little familiar, right? So this is how calculus works. You do one problem, you get to know it well, and then you meet another problem, and you're like, you're basically the last problem that I did, just a little bit different, which is part of why you just need to do every problem that you can find. Like, search them out, try them. The more you do, the better. You just get better and better at doing them. You see patterns. You start to get a sense of like what the answer will be ahead of time, that kind of thing. And going into a problem knowing the answer, or knowing at least like what you expect the answer to look like, is a huge advantage that you just won't have if you don't do enough problems. So let's do this problem and see how it relates to anything we've ever done before. So find the area of the largest rectangle that can be inscribed in the first quadrant region bounded by the graph of y equals 4 minus x over 2 plus x and the coordinate axes. So there's a small issue with this in that I don't exactly know what this function looks like, but it's a really small issue because we also kind of don't care. So here is a thing you end up doing a lot, right? So we're in the first quadrant. The problem says that you can draw a rectangle there. If x is equal to 4, then y is equal to 0, so we know that. If x is equal to 0, then y is equal to 2, so we know that. And then I don't really know what this looks like, but let's just draw something. I'm going to assume that it kind of looks like this. It doesn't honestly really matter as long as, so I definitely know that x is going to be between 0 and 4. Like that has to happen. So I can do the candidates test on this if I want. The other thing I know is that I can draw a rectangle. So I'm going to do that. I'll do it in a different color. So my rectangle, let's say it's this. If I were you, which I'm not, but you know, you're basically me because you're just taking all the notes that I'm putting down. I would avoid trying to draw something that looks like a square, right? Because you don't know that it's going to be a square. And as soon as you draw a square, your brain is like, oh, it's a square. And then you really focus on that, and it can be very detrimental to the solution process. So what did we do last time that we had something like this? Last time we focused in on this point and we said that it could be written as x comma y, but then y is given, right? Y is this. So let's do x comma 4 minus x over 2 plus x. That's our ordered pair. All right, so what is the area of this thing? So the area, we're not going to need a helper function in this case. So the area is just going to be x times y, right? Because it's a rectangle. But y is equal to, or I guess in some sense, y equals 4 minus x over 2 plus x is the helper function. And it was just given. I don't really think of it that way, but now that I think about it, maybe I should think of it that way. So that is our helper function. So it should have been x times y, but we use the helper function to get rid of it. Boom, it's all coming together. And I've been doing this like forever. So that's one of those things. Like the more you think about it, the more you learn. All right, so this is our area. Whew, okay, so I mean, I'm going to expand that because I'm not crazy. I don't want to use the product rule and the quotient rule in the same problem. Sometimes you have to, though. Sometimes unavoidable, but I do not want to do it. So here, a prime. You know, partly to avoid finding a prime right now, we did say that we know that x will have to be between 0 and 4, right, if we're going to stay in the first quadrant. So we also know that. All right, let's find the derivative. No more avoiding it. So bottom derivative of the top is 4 minus 2x minus top. The derivative of the bottom is actually 1, thank goodness. And then over the bottom squared. Okay. So how unhappy are we to deal with this? Pretty unhappy. All right, there's like, I think it's just like expand and go. So a prime is, I'm going to expand this top thing here, and I'm just going to like do it. So 8 minus 4x, oh, look at that, minus 4x plus 4x. That's not that bad. Minus 2x squared. And I get, what? How do I even make that? The only way to really get rid of those, I think, is to like, so what was I doing? 8 minus 4x plus 4x minus 2x squared, x squared. Last time it became a weird little triangle thing. Minus 4x plus x squared. Okay, over no reason to expand the denominator. When you use a quotient rule, there's almost never a reason to expand the denominator, because usually you just set it equal to 0, try to find the zeros, which would involve factoring anyway. Sometimes you just, cross multiply it out. A prime is, all right, so minus 4x, I think it's 8 minus 4x, and then minus x squared, which I hate leading coefficients that are negative. I also am not in love with this 2 plus x that I keep writing in the denominator. So I'm going to take out a negative, make it x squared plus 4x minus 8 over, I'm going to make it x plus 2 squared. Okay, so that does not factor. But I can use a quadratic formula on it, or I could complete the square, whatever. What I'm going to do first, and I know this is like kind of lame, or is it smart? Who knows? I'm going to check on the calculator and see if I got the derivative right, because I just don't want to spend like the rest of my life on this if it's wrong. All right, so a of x is x times the quantity 4 minus x over 2 plus x. Derivative, you should use the template. A of x comma x negative plus minus over that. Yeah, okay, so we're right. All right, back to doing it by hand, which seems silly, but like it's still the world we live in. Like, there are people who are like, they never do anything by hand that you can do by calculus. Like, when you get to college, it's not going to be like that. So you're going to have to be able to do some of these things by hand. And is that good or bad? I don't know. It's kind of like both. Like, it's sad that people don't acknowledge that computers and calculators exist. But by the same token, like, I mean, that's the standard people are using to decide if you are qualified or not. So like, you got to meet that standard. All right, let's see. So a prime equals 0 means, that means that x is, I'm quadratically formalizing this, using quadratic formula on this. So it's opposite of b plus or minus the square root b squared minus 4ac, so plus 32, and then all over 2a, so over 2. So this will be negative 2 plus or minus, what is that, radical 48, which is 4 root 3, but then divided by 2, so 2 root 3. Now, what did we say? We said over here that x is between 0 and 4. So negative 2 minus something is out. So we can do one of those, or therefore. So therefore, x is negative 2 plus 2 root 3. All right, so what are we going to do here? Because I do not want to, I don't really want to do anything on this. I guess I'm going to number line it and then lonely critical point theorem it, I think. But this is going to be kind of brutal. So let's see. I know, what do I even know? All right, I know, so sign chart. What goes on our sign chart? So there's like some symmetry here. So this will be for a prime. So negative 2 goes in the middle. Then we have negative 2 minus 2 root 3. And then we have negative 2 plus 2 root 3, which is the only one we're really interested in. What can we do? So the denominator is always positive, so it's not really impacting us. And then this part, so let me highlight something for you. In the derivative, here, this is a quadratic that opens down, right? So I know a quadratic that opens down is going to go negative, then positive, then negative, because a quadratic that opens down will always look kind of like this, right? So it's going to start negative, then it'll go positive, then negative. The denominator, there's just like a pop sound outside. I don't know what that was. That's why I like looked over there really fast. Sound like something hitting something. I hope nothing happens. All right, so it's going to go negative, positive, negative. And so the denominator is always positive, so I think that I'm safe going like negatives, positives, and then negatives. All right, what's nice about that is that we were looking for the maximum area, and we got that there's a relative maximum at our critical point. So I'm thinking that we're good to go. All right, so let's write that up. So A of x has a relative maximum at x equals -2 plus 2 root 3. And then you got to say why. Because A prime changes positive to negative there. Okay. Relative maximum, that's fine. Since x equals -2 plus 2 root 3 is the only critical point. What? Critical point? Let me blow this way up. A of x has absolute max at x equals -2 plus 2 root 3. So now, what did the question ask? Because I feel like I'm not going to want to answer it. Find the area. Are you kidding me? Nobody wants to do that. That's got to be a calculator. So let's say, therefore, the absolute max area is A of -2 plus 2 root 3. Why won't you do it? Okay. And then I'm just going to use a calculator because look at what we have to sub in. It's not like the function we have to sub into, it's the thing we have to sub in that's my issue. So I'm going to go back to the calculator and let the calculator do it in exactly no time. So let's see if we got this right. Solve the answer equals 0 for x. So so it's -2 plus 2 root 3 is one of them. So that's good. And then, okay, so let's find A of -2 plus 2 square root of 3. So 8 minus 4 root 3. So the maximum area is 8 minus 4 root 3. Let's go back to the notes, write that in, and then we'll be done with this page. And we'll move on to the next page, which, if I'm not mistaken, is the last page of the math analysis notes, which is utterly insane. 8 minus 4 root 3. Okay, how did we get that? We use a calculator because we're not crazy people. All right, so there's our answer. Another lonely critical point theorem. That's going to come up a lot because it's a hard argument otherwise. Like, it's a really good argument that you can make on this one. Could I have plugged in 0 and 4? Yes, but I didn't really want to plug in -2 plus 2 root 3, which I ended up having to do anyway. So maybe I should have done the candidates test. I don't know. I go back and forth on that, right? If there's only one critical point, like, why not lonely critical point? If there's more than one critical point, you definitely need the candidates test. But anyway, I will be back in the next video to, I don't know, like, get really close to finishing this off. It's probably not going to be one video for the next page, but really close. So I will see you there. Hope you're finding these helpful, and thanks for sticking around. So see you then.